Good morning, everyone. I'd like to introduce our project, which is a distributed video transcoding for the Monterey Bay Aquarium Research Institute. I'm Jose Sainz.
I'm Reggie Tequila.
I'm Simone Boyd.
I'm Drew Gutierrez.
So a little description of our project. Embari currently sends out their ROVs underwater, and they take these videos that take up a really large amount of space. So what they wanted to do is have us create a system that automated the video transcoding so they wouldn't have to do it manually, so it's easier for researchers to use for things like annotations. And so these files are around 20 to 40 gigabytes for every 15 minutes. So for reference, most of your smartphones have around 30 gigabytes. So just one 15-minute video takes up more than most of your entire phone. And also they just wanted the process to be automated so it could be distributed between many nodes on the network instead of having to be done on a single machine. And lastly, the converted files would be just a fraction of the original size.
So our approach for our project is we used a set of tools. One of them is Docker. Docker is a software tool that allows us to create a network of virtual machines. And these virtual machines have shared access to Embari's video files. For the machines to communicate, we used a tool called RabbitMQ, which is a task management system for distributed computers. Once the distributed computers receive a message, they begin the transcoding process.
Once we started our project, we were using HT Condor, which is a workload management system similar to RabbitMQ. With this, we were able to set up our network connections among our nodes. However, once we're passing the jobs around, the jobs are showing idle, which leave them unusable. That's when we moved to RabbitMQ. Some problems with RabbitMQ was our workflow. Some of the jobs were being passed to different nodes, which we didn't want. And if the job failed, it wouldn't be requeued. We had a shared network drive with the master node and the consumer node. The master node would take jobs from the network drive, send them to the queue, which then the master node would round robin the jobs to the consumer nodes. And once the job was complete, it would send an acknowledgement message to the master, which would take that job out of the queue.
So here's what an example of submitting a job looks like. So first we type in to get our Python script, which we call file names.py, and then we pass in the videos folder. So we could pass in all the jobs that are in that folder, and then it sends all the jobs to the work queue. And then on the left, where our success, we see what the video transcoding process looks like, and we get a video transcoded message with how long the process took. And on the right, for our failures, we have a message that's saying the video couldn't be transcoded, how long that process took, and that job gets resubmitted back to the queue so another node could successfully transcode the video. And then for some of our results, we have at the top, we see that our original video file was 26 gigabytes, and after we transcoded it, it was 330 megabytes. So that resulted in a 98.7% reduction in the file size overall. And on the left, we have the original ProRes video, and on the right, we have what the transcoded video looks like. So there is some loss in color, but the video quality is still there. And lastly, we'd like to thank our mentor, Brian, and thank you.